Hello everybody, welcome back to the online course on computer organization and architecture. We are in the module fundamentals of digital computer and this is unit number 5, and in unit number 5 we are going to discuss about storage and I/O interface. So, like earlier unit also, for this particular unit we are going to mention the objective. Here we have cited 3 objectives. Objective 1, illustrate the use of system bus. Again we will be dealing this objective in knowledge level. Objective 2, describe the size of address bus and capacity of memory module. So, this is basically on analysis level. So, you will be able to analyze once you get some memory module and you can find out what is the capacity of that particular memory module and what are the other requirements. Objective 3, explain the need of control bus. This is also an analysis level. We are going to see why you need a control bus. So, we are discussing about the von Neumann stored program architecture, and our computer works on this particular model. Already I have shown this particular model. We are having the central processing unit, that I/O equipment and memory module, and whatever we are going to work, everything must be present in the main memory, and processor is going to interact with the main memory and it is going to fetch the information from main memory. And in the top level view of our computer system can be visualized in this particular way. Here we are having 3 main components. One is your CPU or the central processing unit. This is the main processing element inside a computer, and this CPU is connected to main memory, which is the storage unit, primary storage unit, and along with that we are having I/O module. Through I/O module we are going to connect all the input output devices like keyboard, mouse, printer, monitor. Those will be connected through these particular I/O modules, and everything will be integrated through this particular system bus. So, we are talking about a bus. Now, what is a bus actually? So, in that particular case, this bus is nothing but a connecting wires. So, you are going to connect different devices with the help of bus. So, we are having different types of connection in our computer. So, there may be one connection between processor and memory. So, this is for memory interface. We are having another connection between your processor and input output devices, and another kind of connection we are having CPU interconnection. This is basically internal to the CPU. Already I have mentioned in our last lecture that all the components of processor will be connected to each other through our internal CPU bus. So, bus is nothing but a collection of wires through which we are going to transfer information, and basically it is a broadcast methodology. Basically what happens, you can see that if I am having a device, say in this particular case device we are going to talk about say CPU, and say through this particular system bus it is connected to different devices or different unit. So, in that particular case whatever information we are transferring through this particular bus, this is in the broadcast mode and it will be available for all the connecting devices, but according to the need one particular connecting device is going to use this particular information. Secondly, that collection of wires are basically grouped together and you can say this is basically channels. So, number of wires that we are having one particular bus is basically known as the number of channels, and this is basically depends on the number of information that we are going to transfer. So, as for example, if I talk about a 32-bit data bus, in that particular case we are having 32-bit separate signals bit channels. So, we are having 32 different channel. In every channel we can transfer 1 bit of information. That information may be either 0 or 1. So, collecting all those particular channels or wires, basically we say this is a bus. So, what is a bus? Bus is nothing but a connecting wires through which you can transfer information from one point to the other point in that particular bus. Now, there are categories of bus. One, we are talking about a data bus. Through this data bus we are going to transfer data from one point to the other point. Maybe we are transferring data from memory to the processor, or maybe from processor to the memory. So, but when we are going to talk about data or when we are going to talk about transfer of data through our bus, in that particular case or in this particular level, device level, there is no difference between data and instruction. All will be treated as a binary bit. So, as for example, say if I am going to consider about 8-bit numbers. So, if this is an instruction, then what will happen? It is going to interpret as an instruction inside the processor, but this can be treated as a data also. That may be a data for a particular instruction. So, when we are transferring information from one point to the other point or one device to the other device, at that point in the signal level we do not have any distinction between data and instruction, all are in the bit level, either it is 0 or 1. In some signal lines we are transferring 0 or in some signal line we are transferring 1. But when we are going to interpret it, at that time we are going to see whether we have to treat this particular information as an instruction or we have to treat this particular information as a data for an instruction. And width is a key determinant factor for the performance. So, if we are having an 8-bit data bus, then what will happen? We can transfer 8 bit at a time. If we are having a 64-bit data bus, we can transfer 64 bit of information at a time. So, in one go you can transfer 64 bit. So, if we are having more width, basically we said that we are going to achieve more performance, because in one go we can transfer a complete information. There is another bus we call, this is the address bus. This address bus basically identify the source or destination of a data. So, basically what will happen? I am saying that we are keeping our information in main memory. Okay. So, this is a memory location, and already I have mentioned that to go to a particular memory location, we must identify that particular memory location. And how we are going to identify it? It is with the help of an address. But what is the addressing format when we are going to work with our digital computer? Just consider a small example. Just say that in this particular memory module itself, we are having total 8 memory locations. So, I can number them as your 0, 1, 2, 3, 4, 5, 6, 7. So, we are having 8 different memory location, and we are going to take information from say one particular memory location. Now, how we are going to identify that particular memory location? So, we are going to do it with the help of address. Now, what is the addressing format? Now, you just see that if we are having 8 different combination, to identify any one of this combination we need 3 bit of information, because we know that 2 to the power 3 equal to 8, and this particular 3 bit I can say that A0, A1, A2, that 3 information that may go have all 0, 0, 0, 0, 0, 1 like that 1, 1, 1. So, these are the 8 possible combination of this particular 3 bit A0, A1 and A2. So, since these are the unique combination, so we can use those particular combination to identify one of the memory location. Now, how to do it? We are having 8 location and we are having 3 bit of information. So, already we have talked about a decoder. We know that we are having a decoder where we are having some n input lines, then maximum output lines will be 2 to the power n. Depending on the input combination, one of the output line is high. So, in that particular case, what we can do? We can use an 3 by 8 decoder. We are having 3 input lines. Okay. So, this is say A0, A1, A2, and these output lines will be connected to those particular memory location. Okay. So, depending on the information that we are putting over here, it is going to enable one of the lines. So, if I give the information say 1, 1, 0. So, this is the most significant bit, A 0 is the least significant bit. So, 0, 1, 1, this is basically going to represent in decimal 3. So, that means 0, 1, 2, 3, this particular line will be enabled. So, when this line is high, that means we are going to select this particular memory location with the help of this particular line, and this is the combination. So, this combination is basically known as my address to a particular memory location, and you just see that in every memory location we are going to store 4 bit of information. So, in that particular case what will happen? You can think that we are having a data bus which is of 4 bit wide. Okay. Now, along with that we may have one control line or two control lines. Say if I say that this is a line which is giving as name as your read write bar. So, in read write bar what will happen? If this is 0, then we are going to perform a read operation. We are going to take the information from the memory, and this signal is 1, then we are going to perform a write operation. Maybe I can say like that, or maybe it is the other way around. Since it is read, no bar, so 1 is your read and 0 is your write. This is the exact definition you can say, since I am defining it as read write bar. So, when it is 0, then it is a write operation. So, when we are going to perform read operation, we will identify the memory location through address, and whatever we have stored in this particular memory location, that will be available in the database, and through database we can take it to the another device or another component. And when it is a write operation, so whatever information we are giving into the database, that will be stored in this memory location, that whatever we have identified over here. So, in that particular case what will happen? I can see the memory module this one is a memory module. So, we are having input lines called address bus. Through address bus we are going to give the address to a particular memory location, and we are having data bus. Through data bus either we are going to read the information or we are going to write the information, and along with that we are having a control line which is going to indicate whether it is a read operation or write operation. So, in this way we can visualize our memory unit. So, in case of memory unit we are having address bus as well as data bus. Again, the size of data bus basically indicates how many bits we can transfer in one go, and size of address bus basically give the number of memory location that we have in that particular memory location. So, it is a 3 bit, we are going to say 8 memory location. So, if I increase it to the 4 bit, then we are going to get 16 memory location. That means, I am going to add one more bit in the address bus. So, in that particular case what will happen? With A 3 is equal to 0, I am going to get 8 combination, and with A is equal to 1, we are going to get another 8 combination. So, total 16 combination. So, address bus is nothing but collection of words through which we are going to give information zeros and 1, and that combination is going to identify one of the memory location. So, like that we are having a control bus. So, already I have said that we may have a control signal called read and write signal, that we are going to either read the memory or we are going to write into the memory. We may put another control signal which is known as your memory and input output. So, basically just see that this is my processor. Through this particular address bus we are connecting to the memory location. Again, through this particular address bus we are connecting to input output module. Okay. Now, whatever address we are giving over here, that may be either address to a memory location or that may be an address to the I/O device. So, through I/O modules we are connecting several I/O devices. Okay. So, it may be an address to an I/O device. Now, how to identify whether it is an memory address or it is an I/O address? For that we are going to have one more control signal coming out from the CPU, and that control signal will identify whether it is an memory or I/O. So, if I am going to say that memory or I/O bar. So, in that particular case, if this signal is your high, then we are going to say that it is a memory address, and if this signal is 0, then we say that this is an I/O address. So, with the help of this another control signal, we can identify whether we are going to access a memory or we are going to access an I/O. Another signal is talking about the interrupt request, because again it is related to the I/O. So, some of the I/O device is sitting over here, and say this I/O device want to carry out some work in the processor. Then, since during program execution, that processor is interacting with the memory and taking the information from memory to the processor and carrying out its job, and in between this device want to perform some work. So, in that particular case, it will give an indication through another control signal, which is known as your interrupt request. So, those things will be discussed in details while we are going to discuss about the I/O devices. We may have another clock signal called clock signal, because it is in synchronous operation. So, everything will be controlled by a continuous clock signals, and that signal will also come as an input or output to that device. And we may have some synchronization signal, we will see what is that synchronization signal. So, finally, we are having now 3 components, one is your data bus, address bus and system control bus. So, combining all those 3 buses, control bus, data bus and address bus, we are going to say this is the system bus. Okay. So, through this system bus, we are going to connect external devices to this particular processor. Those external devices basically may be some input output devices, and secondly, I can tell that memory can also be treated as an external devices with respect to this particular processor, because memory is sitting outside the processor. So, that means through system bus, we are going to connect the other devices and memory to the processor, and the system bus is having 3 components: control bus, data bus and address bus. Now, already I have mentioned all those things. So, basically we are having memory connection. So, with the help of memory connection, what we are going to do? Receives and sends data, receives address or location, because we have to identify the location also, and receive some control signals. So, basically in system bus we are having 3 components. With data bus, we are going to receive or send our data. We are having address bus. Through address bus, we are going to give the address to a memory location, and through control bus, we are going to receive or send some control signal. One is your read signal, already said that we are going to read the information. A write signal, we may say that we are going to write something to the memory, and some timing information also has to be sent in that particular connection. So, here I want to mention that the speed of processor and memory is not same. Okay, so, we are having a processor CPU and we are having a memory unit, and this is connected through this particular system bus. Now, most of you are working with a computer, and you know that generally used to say that I am having a computer and it works on say 2.3 gigahertz. Okay. Or sometimes you may say that we are having a processor which works in your say 3 gigahertz. So, what does it means? Basically, this is the frequency, operating frequency of the processor. So, what will happen? We are having a continuous running clock, and this is the time period of this particular clock signal. So, this is during this particular clock signal, this is clock pulse, we are going to perform some job or say some micro operation. Then in the next clock cycle, we are going to perform some of the clock cycle. So, this is basically called time period of this particular signal, and when I am going to talk about the frequency, that frequency is nothing but 1 upon that particular time period, and it is basically unit is your hertz. So, that means if we are going to say that it works in 3 gigahertz, that means 3 gigahertz is equal to 3 into 10 to the power 9 hertz. Kilohertz is your 10 to the power 3, megahertz is your 10 to the power 6, and kilohertz is your 10 to the power 9. So, it works in this particular frequency 3 into 10 to the power 9 hertz. That means, in 1 second it is going to oscillate that many times, 3 into 10 to the power 9. So, that means, what is the time period? You can say that this is nothing but t is equal to 1 upon f. So, this is nothing but 1 upon 3 into 10 to the power 9, which is I can say that 0.33 into 10 to the power minus 9. So, this is basically second, millisecond, microsecond, nanosecond. So, 10 to the power minus 9 is your nanosecond. So, that many, this is the time period. So, in that nanosecond 0.33 nanosecond I can carry out one small operation inside this processor. So, this is the operating speed. So, this is that we have achieved this particular 3 gigahertz speeds due to the advancement of the technology, and we are going to use the technology over here, which is a very faster technology. Generally it is a silicon technology, and generally nowadays we are working with the sub-micron level. So, with the help of advancement of technology, we are getting devices which can work in 3 gigahertz. So, but when we are looking for the performance, the cost is also more over here. So, if we are going to use the same technology to make this particular main memory, then what will happen? The cost is going to increase. So, while constructing our main memory, generally we used to use a slower technology just to reduce the cost. So, this is a slower technology we are using. So, here we are having a faster technology. So, somehow we have to synchronize these two operations. So, for that we need some synchronization signal or timing signal. So, some other control signal will come, which will say that when the memory has completed its operation or not, whether data is ready for the processor or not, we have to give some indication. So, some of the control signal will come for that particular purpose also, to synchronize the other unit with the processor. Similarly, when we are connecting some I/O devices, the speed of those I/O devices again still slower, again it is slower than the main memory. So, again we need a synchronization signal for that. So, all those synchronization signal will coming through this particular control bus. So, if I look into the memory, basically that main memory, we talked about this particular main memory, this is basically nothing but a semiconductor memory. So, in case of semiconductor memory, here we can talk about two types of memory. One is your RAM, second one is your ROM. So, RAM is basically, it stands for random access memory. So, RAM is random access memory. So, what is this? Basically, you can see that we are having a memory module, we are having several location, and through address bus we can identify any one of this particular memory location. So, depending on the input or contents of the address bus, we can go to any memory location. So, the accessing of memory location random is nature. By giving a particular address, we can straight away go to that particular memory location. So, it is randomly we can access any memory location. Since we are talking about the random access, there may be some other access also, which is your sequential access. In case of sequential access, we have to access the memory in sequence. So, if it is a sequential memory, then what will happen? If I want to go to this particular point, then I have to go in sequence from the first location to that particular location. But in case of random access, that sequence is not required. Randomly or at any point of time, I can access any memory location. Just I have to give the appropriate address to the address bus. So, it is talking about the random access memory. Another one I have mentioned about ROM. This is read only memory. But again I should mention that ROM, read only memory, is also random access. This is the same nature that we are having, but we can go to a particular location and I can read it. So, what is the difference if I talk about RAM and talk about ROM? What is the similarities over here? Both are random access. And what is our differences? In case of ROM, it is read only. We can read the contents from the memory. But in case of RAM, it is read and write. We can read the information that is stored in the memory. Also, we can write some new information in some memory location. So, both read and write is possible in case of RAM. If I say that it is a RAM, but if we talk about the ROM, then it is only read only. We can read the information from that memory. Again, here I can say that this RAM and ROM can be categorized into two categories. One is your volatile, second one is your non-volatile or permanent. So, when we talk about the volatile, it is basically like that. As long as we are working with the system, that means as long as we are giving the power to the system, then we are going to have the contents in the memory, okay, and we are going to work with those particular contents of the memory. As soon as I switch off the machine, if I remove the power, then what will happen? The contents of this particular memory will go away. So, that is why you are saying it is volatile. So, RAM is volatile in nature. So, as long as power is there, content is there, and we can work with these particular contents, but once you switch off, then all the contents will vanish. If next time if you are going to switch on the machine again, you are not going to get those particular contents. So, it is volatile in nature, but ROM is read only memory. It is a non-volatile memory and it is permanent in nature. So, during the manufacturing time itself, we can write our contents in the ROM, and while working with the ROM, we can simply read it. We can take the information and we can work with the information. So, it is a permanent in nature. So, it is non-volatile memory. And when we are going to give the put the information in the ROM, if we say simply ROM, then during the manufacturing time only we are going to keep our information. Again, we are having several types of ROM, and these are basically, one is known as ROM that I have already mentioned. This is read only memory. So, during the manufacturing time itself, we are going to put the information and that information will be used in our devices. So, this is ROM, but we are having the enhancement, we are having another type of ROM which is known as your PROM, programmable read only memory. So, it is a ROM, but it is programmable. So, while manufacturing, when it will come out from the company, then the contents are null, basically it is a null contents or it is a blank memory. Now, with the help of programmer, we can program this ROM, or we can say that we can write some new information into that particular ROM. So, once I write it, then the contents become permanent. We cannot erase it and it is permanent in nature. Now, we are going to use those particular information. So, this is called PROM, programmable ROM. It can program only once. Once you program it, once we write our contents, it will remain permanent and we can use it. But after programming, if we find that there is some mistake, then what will happen? I have to use another PROM only. I cannot use that one. So, for that we are having next level of ROM, which is known as your EPROM. EPROM is your erasable programmable read only memory. That means, it is a ROM, read only memory, it is programmable, but again it is erasable. So, once you program it, we have written our contents into the memory, but if we find that there is some mistake in some data or some information, then what we can do? We can erase it and we can reprogram it. So, here erasing means erasing the contents of the entire memory. If there is a mistake in only one bit, still we have to erase the entire memory. So, erasing can be done by exposing that particular ROM chip to ultraviolet rays, and once it becomes blank, again we can reprogram it. So, in that particular case, what will happen? If there is a mistake in one particular memory location, still we have to erase the entire ROM and reprogram it. So, for that we are having the next level, which is known as your EEPROM, electrically erasable programmable read only memory. So, this is programmable, it is erasable, but erasing is not like that we have to erase the entire shape. Here it is called electrically erasable. So, in that particular case, what will happen? If we find that there is a mistake in this particular memory location, then we can erase this particular memory location and we can rewrite it. I need not to rewrite the entire things over here, we need not to rewrite the entire memory. So, this is your EEPROM. So, all are semiconductor memory, and those semiconductor memory we are going to connect to the processor to build our computers, which will work as a primary memory. So, like memory connection, we are having input output connection also. So, through input output connection, we can connect input output devices. So, basically what will happen, that input output devices will be connected to the processor through I/O modules. So, what will happen in case of output? It will receive the data from the computer. So, basically what will happen, you can say that this is the processor, CPU, this is the system bus. Through system bus, we are connecting the I/O module, and I/O devices will be connected to this module. So, what we can do? In case of output, it will receive data from the computer and this module will transfer it to the device. So, in case of input, it will receive the input from the device and that module will transfer it to the processor. So, this is basically output device and in this case this is your input device. So, these are the things that we are going to do with the help of input output connection. Again those IO modules will be connected to the processor through the system bus. So, this is the top level connection. Already I have seen this slide, we have seen this slide for several times. This is the CPU, that main memory unit, and this is IO module. Through IO module we are going to connect this particular input output devices and all those things are connected through this particular system bus. Again I would like to mention that system bus is having 3 components: address bus, data bus and control bus. Now, what is an address bus and data bus and what we can store and what are the limitations? Just we are going to give one example. So, we are talking about the address bus. Already while talking about the memory module, what I said that if I am having 8 memory location, then I need 3 bit of address, okay, because 2 to the power 3 is equal to 8 and we are having 8 different combination. Like that, now I am just elaborating it. Now, if the size of the address bus is 8, then what will happen? These contents will go from all zeros to all 1. These are the different possible combination. And in decimal, we are saying that this is 0 or 255. That means, we can address 256 memory location if the size of the address bus is your 8. And this is 255 and here I am just writing it in hexadecimal, because I said that you take 4 bit together and just get the hexadecimal equivalent. So, this is your FF. Now, if I am having 8 bit address bus, in the contents is something like the 0 1 0 1 0 1 1 1. So, if I have this particular contents, then the decimal equivalent of this one is your 87. That means, we are looking for the 87th memory location. It is starting from 08. So, we are going to 87 memory location and from that particular memory location we are going to either take the data or we are going to write data. So, that same information that we can write in hexadecimal, we can say that 57 hexadecimal. So, this is 5, this is 7. So, if the contents of the address bus is your 000 and 0110, so that means this is 6. This is decimal 6 also, in hexadecimal also it is 6. That means, we are looking for the 6th memory location. So, like that we are having total 256 combinations. So, we can address 256 memory location. Like that, if I am going to increase the size of the address bus to 10, then what will happen? It will become now 2 to the power 10, which is your 1023, or in hexadecimal I am saying that this is 3FF, 3FF. So, it will go from memory location 0 to memory location 1023. If we increase the size of address bus to 12, then we can go up to 4095. Like that, if I am having a 16 bit address bus, then we can go up to 2 to the power 16 minus 1. So, that means, if I am having an n bit address bus, then I can go up to 2 to the power n minus 1 memory location. So, total 2 to the power n memory location, it will go from 0 to 2 to the power n minus 1. So, 2 to the power n memory location we can address. So, the size of the memory module that we can connect to the processor depends on the size of the address bus. So, now we are talking about address bus. This is the same slide, but along with that we are talking about the what is the capacity. Now, if it is size is your 8 bit, then total memory capacity is 2 to the 256. That means, we are having 256 memory location. We are talking about these are the location and this is your 256 memory location. We are not talking exactly how many bits we are storing over here, but we are storing saying that we are having 256 memory location. So, similarly, if I am having a 10 bit, then it is 1k. Actually, 2 to the power 10 is nothing but 1024. So, in that particular case, that 1024 memory location is basically written as 1 kilo memory location. Okay. So, this is used as that 1k means 1024, which is your 2 to the power 10. So, this is having slight difference with our metric system. Basically, what will happen if I am having 1 gram or 1 centimeter, then what will happen? I can say that 10 to the power 3 is equal to 100, 1000. So, we are going to say this is your 1 kilogram. Okay. like that we are having 10 to the power 6, 10 to the power 9, which is your kilo, mega, and here it is your gigas, like that, megahertz, gigahertz, like that. So, in metric system we are having 10 cube, 10 to the power 6, 10 to the power 9. But in a binary system, when we talk about a computer, then 1K is your 1024, which is slightly more than 1000, okay, slightly more than a metric system. Like that, 2 to the power 20 is known as your 1 mega, and similarly 2 to the power 30 is known as your 1 giga. Okay. So, this is the information, or we are having it. Now, how we are going to specify our memory, whether it is your mega location or giga location or kilo location. Now, you just see that sometimes you used to say that in your memory you are having 4 gigabyte of memory. What does it mean? We will see these things, we will explain it. So, this is the scenario, and secondly, what about the data bus? So, this is the same thing. If I am going to have a data bus of 8 bit, then I can go up to 0 to 255. If it is your 16 bit, I can go up to 0 to 2 to the 16 minus 1. When we are talking about the number system, at that time we have discussed all those issues. So, now you just see that what is the relationship between that. So, you have mentioned that you are having a computer with 4 GB. You generally say that I am having a memory that my computer is having 4 GB memory. So, it means it is having 4 gigabyte. What is byte? I think somewhere we have mentioned 1 byte is equal to 8 bit. So, if we take 8 bit together, generally we call 1 byte. So, it is having 4 gigabyte. That means you can say that in a simple case, what I can think that it is having 4 gigabyte, and I said that in every memory location I am going to store 1 byte of information. Okay. Then how many memory location we are having over here? 4 giga memory location. Okay. So, see, we are having 4 giga memory location, and in every memory location we are storing 1 byte of information. So, for that, now if I am going to look into it, what is the size of this data bus over here? Since every memory location we are storing 1 byte of information, that means here I am having 8 bit. So, data bus, size of the data bus is your 8 bit. Now, what is the size of the address bus? So, you just see that I am telling you with 3 bit I can address 8 location, 4 bit we can address 16 location, 5 bit we can address 32 location, like that. If I am having your 10 bit of information 1 kilo, 20 bit of information 1 mega, so 30 bit of information 1 giga, 2 to the power 30, and 4 giga is your 2 to the power 32. That means we need 32 bit over here. So, that means if I say that I am having a computer with the memory capacity is 4 gigabyte, basically we can visualize in this particular way that it is having 32 bit of address bus and 8 bit of data bus, and we are having total 4 giga memory location, and in every memory location I can store 8 bit of information. But again I can consider about that 4 gigabyte of memory location, but depending on the organization, what will happen? The size of data bus and size of address bus will vary. So, 4 gigabyte, I am talking about the memory capacity is 4 gigabyte, but we are not mentioning about how many memory location is there. Now, if I am going to look this in that particular way, that in every memory location I am going to store 16 bit of information, then data bus is your 16 bits. Okay. Now, here in every memory location now I am going to store 2 byte. Okay. Since every memory location we are going to store 2 byte, so the number of memory location that we have over here will be reduced by 2. So, here I am going to have 2 giga location. So, in 2 giga location, in every location I am using storing 2 bytes of information. So, finally, we are going to get 4 gigabyte of memory. So, So, since now I am having only 2 giga memory location, then size of this address bus is your 31 bit. Okay. Now, again I am going to consider a memory module with 4 gigabyte capacity, but organization is different. So, in that particular organization what will happen? I can say that the size of my data bus is your say 32 bits. Okay. So, in that particular case, that means in every memory location I can store 32 bits of information. Okay. Now, since it is 4 gigabyte and in one memory location I am storing 32 bits, that means I am storing 4 byte. Okay. Since in one memory location I am storing 4 bytes, so what will be the total number of memory location? You will find that this is your 1 giga location. Okay. 1 giga into 4 byte will give 4 gigabyte. Now, to address 1 giga memory location, what will be the size of this particular address bus? Now, you can very well find it out. This is your 30. 2 to the power 30 is equal to 1 giga. So, you just see that if I am going to talk about that I am having a computer with memory 4 gigabyte, then we have to see what is the processor size. Basically, whether it is a 32 bit processor or whether it is a 64 bit processor, and depending on that you can find out that addresses and data bus. Again we are having some more concept called this is byte addressable. That means though I am having 2 byte in one memory location, we can address byte wise also. I can take 8 bit and 8 bit. So, if I go into that point, then what will happen? Sizes of address bus will be slightly different. You have to recalculate it. Again it will turn out to be 32 only. So, when we are going to discuss about the memory module, then at that time we are going to emphasize on those particular issue. So, now you just see that we are going to connect a memory module to our processor. That memory module is having some capacity. We can say it is a 4 gigabyte or 2 gigabyte or maybe say 4 megabyte, 256 megabyte, and depending on the way that we are storing information, that means size of the memory location, with respect to that we can find out what is the size of the data bus and what is the size of the address bus. Okay. So, these are the things that we are discussing over here. So, what we are talking about, that processor is basically connected to memory unit and I/O devices through system bus. System bus is having 3 parts. One is your address bus, data bus and control bus, and depending on the now by looking into the size of the address bus, we can find out what is the maximum size of memory that we can connect to that particular memory processor. So, if I am having an address bus of 32 bits, that means we can connect a memory to the processor where we can have 2 to the power 32, which is 4 giga memory location, and depending on the size of the data bus, we can say how many bit we can store in a particular memory location. So, this is basically connecting the other components with the processor to build a full computer. So, now just see that we have now discussed all those things. Now, try to work out some work example or test item. So, first question that I have mentioned over here, generally the speed of the memory is slower than the speed of the processor. Why? So, it is in knowledge level only, because we have mentioned this thing in knowledge level, because to reduce the cost of the computer, generally what will happen, we use different technologies to build different component, and the technology that we use to build our memory module is a slower technology. So, that is why the speed is slower. So, basically to balance the cost, actually we need the performance as well as we want to reduce the cost. So, for that we are coming with a slower device, and due to that what will happen, the speed of the memory is slow. Question number 2, I am saying that explain the characteristics of different kind of ROMs. Already I have mentioned that we are having ROM, PROM, EPROM, EEPROM. So, these are the, and you know what are the characteristics. One common characteristic is all are non-volatile, but they are having some other characteristics also. So, I think you can note it down and you can write it down. Question number 3, a memory module contains 1 giga memory location. What is the size of the address bus? So, it is in analysis level. I am talking about memory module contains 1 giga memory location. That means we should have a provision to address 1 giga memory location. Here we are not talking about the capacity of the memory module. We are not saying that it is 1 gigabyte. we are talking about 1 giga memory location. Now, what will be the total size? It depends on the information that we are storing in its memory location. So, if you are storing 1 byte, then this is your 1 gigabyte. If you are storing only 1 bit of information in your every memory location, then capacity of this memory module will be 1 gigabit. So, if we are storing 2 bytes of information in each memory location, then the total capacity of memory module will be 2 gigabyte. So, we are talking about 1 giga memory location. So, what is the size of the address bus? I think you know it. It is 2 to the power 30 is equal to 1 gigabyte. So, size of the address bus will be 30. Now, consider a memory location with capacity 4 MB, 4 megabyte. Okay. So, here I should mention one thing. If I say 4 GB, it means that 4 gigabyte. But if I write 4 G and lowercase b, in that case it is your 4 gigabit. So, this uppercase talk about a byte and this lowercase talk about a bit. Now, this test statement says that consider a memory module with capacity 4 megabyte. What is the size of the address bus and data bus if the memory module is? Okay, this in the analysis level it says if it is byte organized, that means in every location we are going to store 1 byte of information, then what will be the size of the address bus and data bus? If it is word organized, that means 1 word is equal to 16 bit, that means we are storing 2 bits of information. So, depending on that, size of the address bus and size of the data bus will change. Third one, I am saying that long word organized, that means 1 long word is equal to 32 bits, that means 4 byte. In one memory location we can keep 32 bit of address, but total memory capacity is 4 megabyte. So, with respect to that, now you have to identify what is the size of the address bus and what is the size of the data bus. Question number 5, how to distinguish the address of a memory location and the address of a IO device if the same address bus is used for addressing. So, this is simply in the high level, in the design level. So, when we are going to design a computer, at that time we have to resolve all those particular issues. I think I have mentioned something. No, we are using the same address bus, but at some point of time we are going to place the address of a memory location. At some other point we are going to put address of a IO devices. So, we have to distinguish this particular address. So, for that I think we need one additional control signal. So, with the help of one additional control signal we can say what is the contents of this particular address bus. So, this is basically I am just saying that it is in the design level, because while you are going to design a processor you have to resolve that issue at that particular time itself. So, like that you cannot try out with some other example also, and with this I will wind up this particular unit. Okay. So, hope you have understood the matters over here. Thank you very much.